Hi, my name is Muhammad Al-Haris bin Salam. I will explain for section 1. Section 1 is DC high voltage measurement diagram. DC high voltage measurement is similar with a AC high voltage measurement. But DC high voltage measurement have an additional circuit that contain rectifier, smoothing capacitor, resistor and resistive measurement. For the rectifier, the function of the rectifier is to block voltage. Each rectifier block 140 kV, and if have two diode, it will block 280 kV. The diode are in the forward bias. And then there are smoothing capacitor. The function of smoothing capacitor is to smooth the ripple and reduce the effect the higher ripple. And then the function of resistor. The resistor will slowly transfer the current to avoid damage to the smoothing capacitor. Finally, measuring resistivity. For DC, we are using a resistive measuring, and for the AC, we using a capacitive measuring. And for the schematic diagram, there are power transformer that will flow to the secondary unit, and from the secondary unit will flow to the BNCT junction and will go parallel to the frequency converter and picoscope for AC. And for the DC, from the power transformer, it will flow to the HV diode, and then it will flow to the smoothing capacitor, and then will flow to the secondary unit. From there, it will flow to the BNCT junction, and then it will connect to the FC converter and picoscope for the DC measuring. For the safety rule, the brother cooper need to connect properly to these three equipment. First, frequency converter FC. Second, floor pedestal, and finally is secondary unit. After that, we must make sure the length of the cable is fit with the layout. And then, always make sure the laboratory are in clean position. Next, put all the equipment in the right place. Finally, make sure the cage are closed when doing some injection. Thank you.
Bismillahirrahmanirrahim. Next, I would like to proceed about section 2, which is configuring the procedure of setting the kit control and picoscope. Actually, this section 2 is almost same with the previous lab, which is lab 3, which is for AC, and this lab is generally for DC. Okay, first we have a source control, which is to increase the percentage of draft and to increase the gain in the system. Then we got a primary side of transformer progress. It will show source voltage and source current, and the sides will show background noise and VM1 and VM2 for AC. Okay, then we got the system monitoring of secondary side of the transformer with 8 slots. The point at the frequency converter related to the slot in the system monitoring. For VM1 and VM2 actually is for AC, which is VM1 consists RMS and RMS1. VM2 consists of peak and short and RMS2. While VM3 until VM6, which is VM2, VM3, VM4, VM5 and VM6 is generally for DC. For VM3 to measure 3, VM4 for measure 4, VM5 to measure 5, and then finally VM6 for measure 6. Okay, next for alarm system, it indicates red color, means it's not able to do any injection. Show condition when problem exists, and then we need to press red button to reset. Okay, after that, for important section of the picoscope, we have first we have data acquisition. Data acquisition is used to control the number of sample of 4 graph. And second, to set the sample interval and trigger setting. Third, to decide the graph range. And fourth, active which channel being used. 5, choose the coupling that need to be used in the system, either it's AC or DC. And finally, to set the divider ratio multiplier. Okay, for data log, then we have data log, which is to choose which channel will be used. Then we have then to make sure that the chosen channel matching with channel at the picoscope. Then the next important section for picoscope, we have program control, which is to control, of course, to control the system, either it must stop or start. Then must click reset button whenever want to start the system. Means whenever we want to inject to start the lab, we must to reset. Then finally, to observe if there is any error occur in the system. Okay, for finally the setup that need to be done for picoscope. Okay, the first setup, we set the acquisition sample or number of sampling. We need to set the number of sampling at higher value, because the higher the value, the better waveform will appear in our graph. The next step is to set the sampling interval to get the accuracy measurement value. The sampling interval were taken at 2 points, which is from 5 microfarad to 15 microfarad as the example. Okay, then the third step, we have, after that we need to set the trigger setting. The purpose of to set this trigger setting is to obtain the impulse in order to decide the threshold level or range. Okay, next we need to active which channel we must use in the system that being connected with the picoscope. Okay, for this experiment we use channel A. There is 4 channel at picoscope, which is channel A, channel B, channel C, and the last one is channel C. Okay, 5. Then we turn on the coupling signal in the system. We need to choose AC coupling, since the coaxial cable are being connected with VM1 at frequency converter. We need to use AC coupling because it states that VM1 only for AC source. Then we choose the range to set the amplitude range. Then 7, we set the divider ratio similar with the manual, which is 19651.1 V/V. Then we set the offset at 0. Next, active channel A at data log and choose AC. Finally, press the reset button at the program control whenever we want to start or we want to stop the system. Okay, I think that's all from me. Okay, thank you.
Assalamualaikum. Hi, I'm Auni and I will proceed with section 3. Briefly, this section is about calculating the data. We have tabulated the data with values of references that is obtained from kit control and the values of display that we obtain from the picoscope. However, we can see that there is a slightly difference between the value, even though the percentage of the output voltage are similar. There are a couple of differences that affected the error in the value, which are the coupling setting. We have set DC for the setting. DC as a coupling means that a direct coupling which allows both of AC and DC signal to pass through a connection. The DC components which which is a 0 Hz signal that will act as an offset of the signal fluctuates. Sensitivity of the range also contributes the increment of error. We have set the value to a certain level where it makes the sensitivity more accurate. Last but not least, the noise also are affecting the reference value of display and reference. And one of the examples of noise is the noise that coming from the power supply. As conclusion, we can conclude that picoscopes are one of the convenient tools to measure high voltage that have a lot of features and most importantly assuring our safety. Thank you.